Hello, Doctor, sir.
Hello, hello. We'll give a few more minutes for people to come.
Is there a recommended text for this class?
Not really. The text that you used before would do it for digital 1 and 2.
Thank you.
Thank you.
Hello, Professor. How are you?
Hello, Vitali. How are you doing?
Very good, Professor. Thank you. How's Phoenix?
How is your PhD going?
Oh, you know, non-existent.
Non-existing.
Not yet, I should
that you
say.
finished your PhD and master. Now you are working PhD.
Professor,
when are you going to be out?
Oh, it never ends, Professor. Next year. How's the weather in Phoenix right now?
3 digits. 100.
Oh, always.
Yep.
But you were used to this, just like in Egypt.
Trying to.
Fair enough.
I believe we may start now. Welcome all for our class, Digital Systems, EE 331. And would you please open your site, the website of our class? The canvas of our class. This is how it would look like. Now we know to go. Please go to announcement. And you are going to have this announcement course. This is the software that we are going to use. Start downloading it. It is going to take a long time. So start downloading it now. Hopefully in half an hour or so we can see it and use it. Course installation. Is there any problem with downloading?
Seems like it's working.
Okay, since it is working, we can continue while you leave it running in the background. I'll go to number 1, syllabus. This is our syllabus, and this is the textbook you may use. And here you may go through the text, and I'm gonna go with you through the important topics here. If you go to modules, you are gonna see the PowerPoint of the lectures that I'll be teaching, and you are gonna see your lab assignments. Okay? And then you are gonna see the homework assignments. If I open any homework, this one, you can download the homework and see the homework assignments. From assignments here, you need, when you are done, for any homework, you are gonna scan and upload. Scan and upload one PDF file, one PDF file. If you have many programs and many answers, so you are taking screenshots and put them in one PDF and upload. Our grade will be just 50% for homework, and 50% will go to lab and quizzes. 3 labs and 4 quizzes, 50%. And we have here 7 homework assignments. This is 50%. The good news is we have no midterm, we have no final, just doing the homework and the lab. And mainly we'll speak about programming. We're going to be programming. So those will be our assignments. One remark that I want to say, there is no big difference between our lab and lecture. We are going to be doing programming in lab and in lecture. And the way I do it, I explain something, then you start working on it. Whether we are in lab or in lecture, that will be the same case. And of course, I encourage you to work together, except for quizzes. Now let's go to our modules. And please download this lecture, the first one, because we are going to be speaking about it. This is lecture 1. To give you an idea about this course, you learned it in the past, Digital 1, EE 131. With this digital course, you learned how you can use AND, OR, XOR, NOR, all of this to build a logic circuit. Even you manage it to build a counter. So if it happens that you are applying for a job, in a job interview, what will happen? The interviewer will ask you, we need a counter. We have a production line and we need a counter to count the Pepsi cans. Okay? You are going to use AND and OR and make it, and it is working fine. But the interviewer will tell you, you did a great job. We have your contact info, we'll be in touch. Okay, that's it. You'll never hear anything from him back. Why is that? Because we had in the second course, Logic 2, we saw a counter a chip that can do the counting. So why do I care about building this from and or? No one will do that if I have a chip that can do the counting. Integrated circuit, I can buy it for 50 cents and it's going to do the job. So why do we care about this? No. You will be dismissed from this job opportunity. Of course, it is an edge if you know digital too, and you can tell the interviewer, I can use 7494 to do the job. Okay. You are welcome to join us and we'll give you 50K per year. Of course, 50K, it is very hard to pay the debt of your tuition. So, but this is what you get. What about this course, EE 331? The bad thing about Digital 1 and Digital 2, you need to update. If instead of counting 6 cans, I want to count 12, a dozen. Well, I need to rebuild the whole circuit again. And that would be time consuming, expensive, especially if you are replicating this design for other factories or other clients. That would be very expensive. But here, with using field programmable gate array logic, FPGA, I have one module, and this module can do the control of the whole production line, including the counting, timing, sensing. All of those can be done with one cheap modules. And if there is a change going from 6 to 12, all what you need to do is just change this number, not the whole program. It is just changing this number and you are done. So it is money-wise, it is very efficient. And of course, time-wise also, we are saving a lot of time and we are back in business. Moving from one characteristic of my production line to another one, it is just very easy to do it with programming. That doesn't mean that logic 1 and logic 2 are useless. No, it is the same as Ohm's law. We learned at Ohm's law, but now we are using load flow analysis. Load flow analysis that uses 1000 bus that I need to find the bus voltage. It is based from the beginning on Ohm's law, nodal analysis. All of those are there. So the knowledge you gained from Digital 1 and Digital 2 are the basis for building the digital system. You cannot jump into digital systems without the basic knowledge of Digital 1 and 2. This is my introduction about this course and why is it important to be aware of what is said before. And as you can see, 131, it is just combinational logic, gates. And when we went to 133, this is Digital 2, we started to speak about sequential flip-flops. We started having clock to synchronize the operation of many items. So the main difference between 131 and 133 is the clock synchronization. With 131, we had no synchronization. Each gate is working by its own, on its own. No synchronization, but 133, we started getting the clock. For digital system, as I said in my introduction, we are reducing the complexity of the circuit board. Of course, that would lower the power requirement because I have just one module to do many things. I don't have a counter IC, a timer IC. I don't have one-shot multi-vibrator IC. I have just one programmable logic device that is my FPGA, Field Programmer Gate Array, that we're going to use. And it will make our reliability much higher. Design flexibility, I can change the design as we said. Here we are going to learn how to use VHDL. This is very high speed integrated circuit hardware description language. Very high speed integrated circuit hardware description language. Very high speed integrated, this is the V. H is hardware, D description, L language. Perhaps you might have learned some Verilog in Digital 1 and Digital 2. But here we are going to concentrate on VHDL. Since we are going to be speaking about field programmer gate arrays, those are the main manufacturer of FPGAs. And those are what they are producing. Each one of these is a family. Under this family, there are many FPGAs models. And this is the software that each one will be using and the website. We are going to be using Altera, and we are going to use this software, Quartz, the one you are downloading right now, and it is from altera.com. This software, the one I am giving you, it is not the latest version, but it is the most compatible with the FPGA that you will get during the lab. We need to be in the lab, so we have James Ballard with us here, and he will be giving you your FPGA on Tuesday. On Tuesday, when you go to the lab, he will be there with you and he will give you the FPGA. If you want to remain in the lab, you are welcome. If you want to go home and work from home, whatever you like. And I am trying to record my lectures, so it will be available for you. Now, let's continue with the lecture. As I mentioned, you need to review EE131 and EE133. Now it says, please read the tutorial and complete the work, the lab work available on Canvas. Let's go to Canvas and see what do we have. These are my lectures, labs, homework assignment, reading material. Oh, very good. I have here for you what? VHDL tutorial. This will be very good start for you. We have a tutorial on the software that we are going to be using. This is the Altera, and we'll be doing that. But I encourage you to go with this first. And this is the FPGA user manual. You keep it handy all the time. We may need it. And those are PowerPoints about shift register, counter, and programmable logic devices and counter. I urge you to download and read those. Those are from Digital 1 and Digital 2. Those are the most important ones that are going to be used frequently. So you need to review those PowerPoints. And this is how to use test bench. Let's wait until we get to it, maybe in week 2 or 3. Oh, this is the same thing. Let me delete it. So what you need to do is read the PowerPoints, and please start reading and practicing this tutorial. This tutorial and the PowerPoints. In our introduction to VHDL, we are going to be covering these points. We're going to start with the structure, how a program in VHDL would look like. What are the signals and constant that we'll be dealing with? The operators, add, subtract, multiply, and, or, and how to model different circuit structures. Multiplexer, for example, counter. I don't need to buy a counter. I can have a software, VHDL, to do the counting. And of course, we are not going to write every piece of program. We have the IEEE standard logic library. We are going to use many functions that are already there. And of course, we are going to have our code that is written in English. I need to convert it to the machine language so the VHDL can convert from this high-level language to the machine language and download it to the FPGA that you are going to get. So we are going to see compilation and simulation. For this VHDL, we are going to use, as I said, the VHDL IEEE standard library, and it will allow us, the VHDL, to go with modular top-down design technology. What do we mean by that? I mean by that, I can have 2-bit adder. I am adding just 1 bit to another bit, and maybe there is a carry. I built this one. I built it as software. What will happen if I have 16-bit carry, not 1 bit? The modular means I am making a module or a component, and I am calling it 16 times. So I don't have to build it 16 times. I am just calling it 16 times. This is modular. So we have the VHDL language that I can use to simulate my system. Even before downloading it to the FPGA, I can do the simulation and make sure that when I download it, I'm not going to get 100% error-free, but I'm going to get maybe 98, 97% error-free. But where the error will come from? It may come from timing. It may come from noise that is happening around your FPGA module and your communication line. All of those can cause some errors, but when I do the simulation, at least I can get rid of logic errors. Many of the timing errors, I can get rid of those by using the simulation. Then I am gonna synthesize my circuit. Means I am gonna check it and translate it to machine language and download it. And as I said, I may need libraries to help me in my programming to make my life very easy, but not building every piece of the program, because there are functions that are in this library. I can just call the function and use it. Now we're going to speak about the data types that we may use in programming, VHDL programming. We have bit, and this bit is 0 or 1. We have Boolean. Boolean, it is true or false. Integer, whole number, no fractions. It can go from -2 to the power 31 up to 2 to plus 31. Positive, this is integer also, but it doesn't start from -31. It starts from 1. Neutral, what is it? It is another integer, but starting from 0. So I put integer, starts from -2 to the power 31 to plus 231. Positive starts from 0 to plus 231. Neutral, that starting from 0 to 231. A real number, this can accept fractions, and it is from -1 to the power 38, -38, yes, to plus 38. We have characters. A, B, C, D, all of those are characters. Even 9 and 8, I can consider them a character. I can use them as a character, or I can use them as integer. If I'm doing math with them, they will be integers. But if I'm just printing the number 9, I'm printing my phone number, my date of birth. I'm not gonna use that in mathematical operation. No, just it is a number. So I am using it as a text of character. Time is measured in seconds or millisecond, microsecond, nanosecond. All of those will be time. Now this is the structure of VHDL program. It starts with the libraries that we are going to use. IEEE, very good. But there are many packages within it. So instead of loading everything with me, I'm gonna state just the packages that I'm gonna use. Here, this is IEEE.standard_logic_1164.org. This is the one I'm gonna use. Library and package. Then the next part in any program that I'm gonna be writing, it is called here the entity. Entity is a very important component, and we're going to see how to write the entity. But the entity, it tells the program what are my inputs and outputs. I am going to get input signals and I'm going to produce output signals. My whole system will have input and output signals. For example, if I have this AND gate, I have here A and B, and this is C. If I look at this one, what is my input? What are my inputs and outputs? Alexis? Alexis? Hello, Alexis?
I'm here.
Hello, hello.
Hi. The inputs are A and B and the output is C.
Excellent, excellent. Okay. My system is expanding and I am getting here D and E. Let's see whose turn. Ben?
Yeah, good morning, Professor. How are you?
Hello, sir. How are you doing?
I'm doing great.
Now I changed the structure. What are my inputs and outputs now?
Your input are C and D, and your output is E.
Let's go from the beginning. Go from left to right. What are my inputs? My inputs, that means I am communicating with the outside world. Getting from outside world,
Okay.
inputs, signals, inputs, and
Yes.
I am giving output. So what?
Your input is A and B, and your output is E.
A, B, and what?
E.
D. What about
E.
C? What about C?
C is an output of A and B, but it becomes an input to E. C and D becomes an input to E.
So is it input or output?
I would say it's an input to E.
Is it connected to the outside world?
No, it's not.
So it is not input or output.
Okay.
Okay?
Okay.
This is the big trick. Input and output that I put in the entity here. In the entity here, I put how do I communicate with the outside world? I'm communicating through A, B, D, and giving output E.
Yes.
Okay? So those are my input output that must be declared. In the entity section, I should tell it A, B, D are inputs, E will be output. In this section, I need to tell it A, B, D, E. What type of signal I'm gonna get. Is it digital? Is it analog? Is it date or time? What kind of signal? Real, integer? So all of that will be specified here in the entity. What about C? It must be declared. It is output from the first AND, and it is input to the second AND. So it is not input or output. It is this one, signal. It is internal signal. Any signal, we call it just internal signal. Now we are in this last big box, architecture. What is architecture? It is the brain of the whole thing. That is where my logic will go. It starts with a small box component. In this component, I gave an example of a counter or a adder. I made 2-bit adder. This will be here. But to use it several times, it will be between begin and end, calling it several times. I can have it even in another file, in a separate file, and still call it from here. So begin, end, that's where I put my program. The component is the small module that I am building, that I may call several times. Signals will be to declare the internal signals between my component. So the first part, the standard logic, IEEE, and those are the packages that I'm going to be using. When we speak about the standard logic, I can have with this standard logic many values. It can be U, that means uninitialized. X, that is strong. We're going to see what the difference between strong and weak. It can be 0, logic 0. It can be 1, that is 1. Z means high impedance. We're going to explain those. Weak drive 0, weak drive 1. We mean by weak drive this is the output, for example, here. I can have here +5 volt or 0 volt. This is strong. But sometimes this AND is not capable of driving and giving current with this 5 volt or 0 volt. That's why I may use pull-up resistor. This is 5 volt. If I have a low, this one will be connected to my ground. If it is grounded, it will be 0, nothing. If it is high, it will be disconnected from the ground, and I'll be taking the current from my external supply. That's why we called it weak, because it needs a pull-up resistor, or strong that doesn't lead. It depends on the output pin you are using. You can go with strong or weak. What is high impedance? I can have my switch connecting me to 5 volt. That will be high. The switch can connect me to ground. It will be 0. Or it can connect me to nothing. This will be high Z. I'm connected to the air, so it is high Z. Why do I put it on high Z? Because maybe the same wire I am using to give an output, now I'm going to use it by another source as input. So I put it for this one as a high Z, not to affect the current coming into it from other, because I have here a bus. Bus can take output or can take input. So I want to disconnect from one and be ready for the other. So I put it on high Z. Signals, we saw C as a signal because it is input on one side and output on one side. I can say my signal, I have to give it a name, or this is the list of signal names, and type. Type means, is it integer? Is it real? What type of instance? And here I put an initial value. This is optional. I can start it with 5, 6, whatever. Like this example. A is my signal, and I'm stating it as a vector, not one number. It is from 7 to 0. From 7 to 0. Chad? Chad?
Yes.
From 7 to 0.
Mhm.
How many bits are there?
There would be 8.
Excellent. 0, 1, 2, 3, 4, 5, 7, 8 bits. Semicolon equal means I'm assigning it to the value between the two codes. All of them are going to be 1. Okay? Now I am declaring it to be logic, and all of it will be 1. What about the next one? It reads differently. I am assigning it to XA5. What does it mean? X means hexadecimal. Hexadecimal. And I have here 2 digits of my hexadecimal. And each one is 4. 4 bits and 4 bits. So the first 4 will be hex 5, and the next 4, the highest 4, will be hex A. So this will be transferred, and it will be the starting point of B. A will be all ones, and B will be A5. Constant, I can declare a constant. That means in the program, it will never change. It will never change in my program. Like what?
May I interrupt? Would you go back over the signal B, the XA5 again?
Okay. Here is it. We said I have this end. I have another end. This is A. This is B. I have here C. I have here D. I have here E. I built this system, the green one. What is outside the green? It is A, B, D. I need those to come from the outside world to get the output E, to give the output E to the outside world also. So what is coming, or my communication with the outside world, it is A, B, D, and E. A, B, D, they have one way, giving input. E, it has also one way, giving output. So A, B, D will be in my entity as input, and E will be also part of my entity as output. What about C? C, it is internal to my box here. It is for the first AND gate, it is an output. For the second AND gate, it is an input. So since it is not part of my outside world and it is internal to my system, I call it signal. C is a signal, internal signal. Clear?
Clear.
Okay. We may now proceed. Operators. Those are my operators, AND, OR, XOR. I have a relation, greater than, less than, equal, not equal. I have shift register, shift right, shift left. Adding operators, that is plus, minus, and this, and it is concatenation. That means if I have 4-bit and 4-bit, I can combine them to make 8-bit. This is concatenation. I'm not adding them. I am just concatenating them, making them as a one, a big one. And we have unary signs. That means I can have plus or minus, negative number or plus number. I have the multiplication operators, that is multiply and divide, modulus and remainder. If I divide 10 by 3, it is 3 plus 1/3. The modulus is 3 and the remainder is 1. We have the not absolute operator. And of course, if I have many of those in one statement, VHDL gives priorities. The priorities is going from 7 to 1. That means if I have multiplication, it will be done before the addition or subtraction. That is how it goes. And of course, I can give extra priority by using parentheses. If I say A plus B times C, how it will be executed? B times C will be done first. Then I will add A. So it is B times C plus A. What will happen if I put parentheses? It will be A plus B, and the result will be multiplied by C. So I'm giving precedence to the addition by using the parentheses, right and left. This is a statement that I can use. As you can see here, I am translating the circuit we had before. What do we have? E is my output. It is assigned. This is arrow equal. This is assignment statement. What does it take? It takes ANDing A and B, ANDing A and B. This is one input. And the result will be ORed with D. So it is D ORed with A and B AND. That's how I may write it. I may write it differently. Here you can see I am saying C, it is A and B. And E will be C or D. Both of them will give me the same results. Please remember, if you are using the second one, C will be a signal, not input, not output. I believe I should stop here. Do you have any questions?
Professor, in that previous example, can you go back to that slide?
Okay. Yes, sir.
Let's say you were,
Let me share the screen. I forgot to share it.
okay, no problem.
Can you
Okay,
see?
so yes, sir, thank you. So let's say you were going to write that concurrent statement, C or D yields E. Would you first have to assign or write out that C equals A
No.
and B?
No. It is not here at all.
Oh, okay. But if
Not
you were
here.
like writing, if you're writing the script though, like the
No,
like the
I'm gonna
code.
write this. This reads the result of A and B, whatever it is. I didn't give it a name here.
It's just arbitrary. So we're just assuming it's C.
It is the output of A and B. Yes, you can assume it's C, but I don't have to declare it anywhere as a
Oh,
signal.
okay. You don't have to declare it. Okay, that's all I wanted to know. Thank you.
Okay.
All right. Well, thank you, Professor.
Thank you all. See you Friday. Please continue downloading because we cannot keep on just talking. We need to play. Okay?
Thank you.
Thank you all. Have a great day. Bye-bye.
Thank you.
Thank you. Bye-bye.